So here we're going to look at the three main categories of electrodes and half cells that we're going to study, okay, that we're going to learn about. There are three broad categories of redox equilibria that we will be looking at. Okay, so if you have a redox equilibrium, okay, the first type is between a metal and its ion, right? A metal and its ion, right? So those are the ones where we've seen we have, you know, for example, copper ion in equilibrium with the solid metal, right? Or we had zinc ions in equilibrium with zinc metal, right? These types of half cells, okay, are going to have an electrode, okay? The electrode will be made of the metal itself, okay? The electrode is that particular metal. So if you have a metal and its ion in equilibrium, so if you have a copper 2 plus copper half cell, right, the electrode will be made of copper. If you have a zinc 2 plus zinc half cell, then the electrode will be made of zinc. The second type of electrodes or half cells that we're talking about, okay, second types of electrodes or half cells that we learn about are electrodes or half cells in which we have non-metals, okay, in equilibrium with their ions, right? Non-metals in equilibrium with their ions. Okay. Now, if you have this type of an equilibrium, then you're going to have an electrode made of platinum. Okay, you're going to have an electrode made of platinum. So examples of this type of half cells are, if you had, let's say, a chlorine and chloride half cell, right, or maybe an iodine, an iodide half cell, and so on, right? We've looked at the standard hydrogen electrode, right? We had hydrogen H plus and H2, right? Here we have non-metals in equilibrium with their ions. So the electrode has to be conductive, but you don't want the electrode itself to participate in the equilibrium. Here the electrode, right, the metal is participating in the equilibrium, so the electrode is made from the same material. Here the electrode, which will be your metal, does not participate, so you want an inert conductive material. So your electrode will be made of platinum. The third type of half cells that we study are, or redox equilibria that we study are, where we have an equilibrium involving two different ions in different oxidation states. Okay, so right, ions with different oxidation states, right? So for example, we can study the equilibrium between iron 3 and iron 2. Right, here again the metal itself, the solid metal, is not involved, right? We have an equilibrium between two aqueous ions, right? You can have the equilibrium between manganate 7 ions and Mn2 plus ions. Okay. Again, in this case, we don't have the metal involved in the equilibrium, so the electrode has to be conductive but inert. Okay. So the electrode will be made of, what? Platinum. So these are the three different types of half cells that we study about. We have half cells, right, where we have a redox equilibrium between an ion and a metal, a solid metal. In that case, the electrode will be made of that metal itself. We have redox equilibria between non-metals and their ions, right? So in this type of an equilibrium, okay, where we have a non-metal and ion in equilibrium with each other, this type of a half cell, the electrode will be platinum, because again, the metal or the electrode is not participating in the equilibrium, right? So it's conductive but inert. And same thing if we have two ions in different oxidation states in equilibrium with each other. This type of a half cell where we have this type of a redox equilibrium, again the electrode will be inert but conductive, so we're going to use platinum. Alternatively, instead of platinum, you will also see graphite being used, okay, but platinum is the common material. One note I want to make here is that for standard electrodes, okay, for standard half cells, okay, or standard electrodes, right, your electrolytes, okay, the electrolytes will be 1 mole per dm cube solutions. Okay, you should have 1 mole per dm cube of solution of every ion present in equilibrium, of every ion present in the equilibrium.